There are these animals that came from off-world. These are pariahs. NASA, well known for its basic divulgences, has indeed uncovered that this new planet isn't just charming, taking into account the truth of its size and region, but also considering the reality that it shows lights that have all the appearances of being artificial. Are we on the verge of uncovering insider truths that could change our perspective on the universe? Could this discovery ultimately mean that there is life on other planets? In 2007, NASA launched the Dawn spacecraft with a mission to examine the most intriguing objects in our solar system. Dawn was marvelously equipped with 3 ion engines, allowing it to embark on an extraordinary journey. Dawn's excursion began with a 14-month assessment of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data revealing Vesta's puzzling surface and diverse geological features. After completing its primary mission at Vesta, Dawn set out on the second and perhaps most captivating part of its journey, a close evaluation of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and embark on a mission to reach Ceres, an achievement that conventional chemical propulsion would have found challenging. These engines provided a consistent, gentle push, enabling Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. First discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of around 950 kilometers, Ceres is the largest and most significant body in the asteroid belt and one of the most fascinating due to its unique characteristics. As Dawn advanced toward Ceres, scientists eagerly anticipated the first detailed photographs of this enigmatic world. They observed bright spots scattered across its surface, most strikingly in a massive crater now known as a Cater crater. These bright spots ignited immense interest and speculation among scientists. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Researchers had limited knowledge of this dwarf planet, and the opportunity to finally get a close-up view was thrilling. What mysteries would Ceres reveal? What new discoveries awaited? The Dawn mission promised to improve our understanding of the solar system's development and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This led to speculation about cryovolcanism on Ceres, a process where volcanoes erupt with water or briny liquids instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about Ceres? Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres stands apart from other celestial bodies in the asteroid belt due to its size, mass structure, and potential for water and ice. Unlike most rocky asteroids, Ceres has a composition more akin to a comet, suggesting that it holds more secrets about the early solar system than previously imagined. After 2 years on its journey, the Dawn spacecraft finally approached Ceres in mid-2015. This moment marked a critical milestone in the mission, as Dawn provided humanity's first close-up views of the largest object in the asteroid belt. As Dawn drew closer, the images of Ceres became increasingly detailed, offering glimpses of a world previously shrouded in mystery. The initial images revealed a surface marked by craters characteristic of a long history of impacts. However, it wasn't just the craters that captured the attention of scientists and space enthusiasts. Among these features were strange bright spots that stood out starkly against the darker, rugged terrain. As the resolution of the images improved, speculation grew about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something even more unique? Theories ranged from mineral deposits to possible signs of cryovolcanic activity. Closer examination revealed that the brightest spot was not a single entity but a collection of several distinct regions. This discovery only deepened the mystery. The hypothesis that these were salt deposits left behind by sublimating water gained momentum, suggesting that Ceres had or still has some form of geological activity capable of moving water or briny liquids to the surface. These revelations challenged existing ideas about Ceres, revealing it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. Ceres is an intriguing world, often described as a cold planet with a harsh yet fragile surface. Unlike most asteroids, which are composed primarily of rock and metals, Ceres stands out due to its unique composition. Its surface is a mixture of water, ice, and hydrated minerals, including clays and carbonates, giving it a significantly lower density compared to its neighbors. This composition suggests that Ceres contains a substantial amount of water. Its surface layer is rough yet permeable with ice and other volatile compounds trapped inside. This cold characteristic is more reminiscent of a comet than a typical asteroid, hinting at a history that may have involved a mixture of rocky and icy materials. Beneath its surface, Ceres reveals even more fascinating aspects of its structure. The dwarf planet is believed to have a differentiated interior consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up around half of Ceres' total volume. This mantle, possibly a mixture of rock and salty water, surrounds a core that may be composed of denser material, possibly silicates. The presence of so much water ice suggests that Ceres may have once held liquid water, especially if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and raises intriguing questions about its geological activity and the role of water in its evolution. However, that isn't all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder region of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this fascinating dwarf planet, but also provide significant clues about the processes that govern the evolution of icy bodies throughout the solar system. Cryovolcanism is a unique and somewhat unfamiliar geological process, especially when compared to the more conventional volcanic activity on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles such as water, ammonia, or methane. On Ceres, cryovolcanoes operate by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it rapidly sublimates, transitioning directly from a solid or liquid state to gas, leaving behind bright reflective salt deposits. These salt deposits form the mysterious bright spots observed on Ceres' surface, particularly in a crater. One area known as Spot 5 has drawn significant attention due to its high reflectivity and the unusual fogs observed by the Dawn spacecraft. These fogs are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred relatively recently. The presence of these bright spots highlights the unique nature of Ceres and raises important questions about the potential for life in our solar system. The Dawn mission has not only expanded our knowledge of Ceres, but has also changed how we view small celestial bodies in the solar system. As scientists continue to analyze data, we may soon unravel even more secrets about this captivating world and its potential to reshape our understanding of planetary evolution. The revelations from the Dawn mission raised profound questions about the potential for life beyond Earth. Scientists have long speculated that celestial bodies with subsurface water could harbor microbial life, much like the hydrothermal vents in Earth's deep oceans. Could Ceres be such a place? The presence of briny pockets, cryovolcanism, and organic compounds suggests that Ceres may have once had conditions conducive to prebiotic chemistry, the kind of chemical interactions that precede life. If liquid water exists beneath its surface, even in small amounts, it could provide a stable environment where microbial organisms might survive. However, while these discoveries are exciting, Ceres lacks an atmosphere that could shield life from the harsh radiation of space. If life ever existed on Ceres, it would likely be hidden deep beneath the surface, protected from extreme temperatures and cosmic rays. The future of Ceres exploration. The Dawn mission ended in 2018, leaving behind a treasure trove of data that scientists are still analyzing. But as technology advances, future missions to Ceres could provide even more answers. NASA and other space agencies have proposed follow-up missions that could include landers or even drills to explore beneath Ceres' icy crust. Such missions could confirm the presence of liquid water, analyze its chemistry, and search for possible biosignatures. Some researchers have even suggested that Ceres could serve as a stepping stone for human exploration. With its abundant water ice, it could provide valuable resources for future missions to Mars or the outer solar system. Water can be converted into oxygen for breathing and hydrogen for fuel, making Ceres a potential outpost for deep space travel. The discoveries on Ceres are part of a larger pattern in planetary science. Across the solar system, we are finding more and more evidence that water once thought to be rare beyond Earth is actually quite common. From the icy moons of Jupiter and Saturn like Europa and Enceladus to distant dwarf planets like Pluto, evidence suggests that liquid water may exist beneath the surface in many locations. Each of these places represents a potential habitat for extraterrestrial life, challenging our previous assumptions about where life can exist. The study of Ceres not only expands our understanding of the solar system, but also brings us closer to answering one of humanity's oldest questions: are we alone in the universe?